Hey guys, Mr. T here. This is another video. This one's on equation of a line. Apologies in advance for the voice. I'm feeling a bit sick. So what's this about? Any straight line can be represented by an algebraic equation or a simple equation. That equation, what it is a rule that connects the x and y coordinates of all the points that are on that line, because a line is like an infinite number of points all right next to each other, and the equation tells you a rule that connects the x and y coordinates of all of those points. For example, this is an example of an equation of a line. Y is equal to 2x plus 3. So what is that rule? For every point, therefore every point on the line, y coordinate of the points is the x coordinate times by 2 and add 3 to whatever that is. So every point of that line, and there's an infinite number of points in that line, every little point in that line follows that rule where the y coordinate is whatever the x coordinate is times by 2 and add 3 onto that. So let's have another example here where I actually draw it. The line equation, if y is equal to x. So what's that saying? That tells you that any and all points on the line, the x coordinate is exactly the same as the y coordinate. So for example, 1, 1, 2, 2, 3, 3, 4, 4. There's no stuff that needs to be done to the x to tell you what y is. It's just straight up equal because y is equal to x. So what would that line look like if I draw this the Cartesian axes on here, so I can draw the lines. Go across. Oh, not the neatest because it's using an Apple Pencil, but you can see what I'm trying to do here. Go along those lines. The origin. So the line equation where y is equal to x. One of the points is going to be 1, 1. Next point is going to be 2, 2. Another point will be 3, 3. Another point will be 4, 4. If the x is equal to the y, then negative 1 would also be negative 1. Negative 2 would be negative 2. Negative 3 would be negative 3. You could go on. It could be like 1.1 to 1.1. And that would be sort of like there, right next to 1, 1. And so you can see, if you coloured all that in, if you went to the extreme, like 1.2 to 1.2, that would just be a tiny bit above. You could connect all of these dots. They'd form a line, okay? I'll put in the negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. You can see it's forming a straight line there. So that is how, hopefully you can see from that very simple example, an equation defines a line, because it defines every point in that line. It tells you the connection between the x and the y coordinate. Let's do a trickier one. Let's do this y is equal to 2x plus 3. So, if the x coordinate was 1, what would the y coordinate be? Well, 2 lots of 1 plus 3. 2 lots of 1 is 2 plus 3, it's going to be 5. So when x is equal to 1, y is going to be 5. So that is going to be, the first point is going to be 1, then 5 up. 1, 2, 3, 4, 5 there. Alright. What about when x is equal to 0? Y is equal to 2 lots of 0 plus 3. 2 times by 0 is 0 plus 3 is that. So, when x is equal to 0, one of those points, y is going to be 3. So it's going to be there. Let's do another point. Y is equal to 2x plus 3, but this time let's make x equal 2. 2 times 2 is 4, plus 3 is 7. So when x is equal to 2, y is going to be 7. That's up there. So you can see a line forming there too. Alright, so that is showing you a slightly more complicated equation and how it forms a line, y is equal to 2x plus 3, and how the x coordinate is related to the y coordinate being 2 times by 2 plus 3 gives you the y coordinate. Okay, so I should draw the arrow this way. So that's it graphically. Another thing to think about here, for any non-horizontal or vertical line, so if it's diagonal, if it's going like that or like that, the equation of the line is going to look like this. Y is equal to mx plus c, or something x plus something else. We call it m and c here because those mean something mathematically. Okay, in this equation, m, it tells you the gradient or the slope of the line. We've already gone over what the gradient means. It's the y step over the x step, and c is the y-intercept where the line crosses the y-axis. So you can actually see that from this example here, the y is equal to 2x plus 3, because just below I've told you y is equal to mx plus c. M is the slope or gradient, and c is the y-intercept. If y is equal to 2x plus 3, slope is equal to 2. As a fraction, that is 2 over 1. That means it's a y step of 2, x step of 1. And you can see that here. This line, every point on that line, you go across 1, the x step of 1, and a y step of 2 going up. Cross 1, 2 up. So that's your slope working. Here, the c tells you the y-intercept of 3. Where does this line, y is equal to 2x plus 3, cut through the y-axis? Here, at y is equal to 3. So there, you can see what the y is equal to mx plus c means when m is the gradient or slope of the line and c is the y-intercept. Next, because the equation y is equal to mx plus c is a rule that applies between x and y coordinates of the point, you can also use it to check if points lie on a line. So these are sort of the exercises you're going to be doing in the book. It's going to ask you, okay, here's a equation of a line, for example this. Can you check if certain points lie on that line? And because you've been told that the equation tells you the rule that connects the x and the y, if the equation doesn't work, then the point doesn't lie on the line. So let's work through this. You're asked, does 2, 5 and negative 1, negative 5 lie on the line 4x take 3? So 2, 5. This equation has to link 2 to 5 correctly if you do 4 times by 2 take 3 equals 4 times by 2 is 8, take 3 equals 5, so that's correct. That tells you the y. So 2, 5 does lie on y is equal to 4x take 3. Okay, because it followed the rule connecting the x and the y, which was 4 times by x take 3. What about the next one? Y is equal to 4x take 3. We're being asked, does negative 1, negative 5 lie on the line? Okay, let's see if it follows that rule. 4 lots of negative 1 take 3. 4 times by negative 1, negative 4 take 3. negative 4 take 3 is negative 7. That is not equal to negative 5. So, negative 1, negative 5 does not lie on y is equal to 4x take 3, because it doesn't follow the rule connecting x and y, which is 4 times by the x take 3. So hopefully that helps you out with understanding what the equation of a line does, and then how to use it to find where the points lie in the line, and I'll see you on the next video.